Kidney? I mean, Kadane's algorithm is a very popular technique to solve a lot of DSA problems like maximum sum subarray.
Or as I like to call it, topic that brings you a lot of views.
What the fuck? So in this video, we will go through the step-by-step process of implementing Kadane's algorithm in JavaScript and also calculate the time and space complexity of this algorithm. Alright, so let's just first understand what this problem is exactly. So we've been given an integer array nums and we have to find the subarray with the largest sum and return its sum. So let's say we have this array over here and we have to find out which subarray has the largest sum. Now what is a subarray? So this can be a subarray, this can be a subarray, this can be a subarray, even one single element from an array can be a subarray. But it has to be continuous. So for example, I can say this is a subarray, -2, 1, -3, but I can't say -2, 1, 4. This can't be a subarray. This is a subsequence. So this over here will be called a subarray because this is continuous, right? This is a continuous. Or we can say -3 as a subarray, right? So all of these are examples of subarray. In this question, we're supposed to find out which subarray has the largest sum. In this case, this 4, -1, 2, and 1 have the sum of 6. So this is the subarray with the largest sum. Similarly, in this other example, if you add all of the elements of this array, in fact, that is also called a subarray. An array itself is a subarray. So that over here will give us the output 23, and that will be our output. This is just for the explanation. This won't be a part of our output. We are just supposed to give this array over here, and we have to get this largest sum that a subarray can give us from this array. Let's forget about everything for a second, Kadane's algorithm and all of those things. Let's just try to first come up with a solution, which can be a brute force solution or an unoptimized solution. Because if you remember from my previous videos, that is what I taught you. That is what you are supposed to do first in a real interview. You are first supposed to come up with a solution. Doesn't matter if it's optimized or not. So let's create a function over here called max subarray, and it's going to take nums as an input, which is an array. So let's discuss what our approach is going to be for this. So obviously, if we want to calculate the maximum sum for a subarray in this question, what we can do is we can take all of the subarray that this array can create and calculate the sum for all of them. And then we can know which one has the largest sum by comparing all of them, right? So what I can simply do is let's start with this -2, and I'm going to take a variable over here. Let max sum to be nums of 0. I'm going to consider that this is the maximum sum right now. And then I'm going to loop through this entire array. So for looping, I'm going to use a for loop, which is going to start from 0 and it's going to go to nums.length, just like this. So we will have one loop that is going from -2 to 4. And then we are going to have another for loop, which will start from, hold on, let me just write it out, which will start from I. That is the current index, and it will go to the very end of the array, that is nums.length. So why am I doing this? See, first I'm going to start from -2. So for this j loop, what I'm going to do, I'm going to take, okay, this is the first subarray, okay, this is the second subarray, let's calculate the sum for it, okay, this is the third subarray, let's calculate the sum for it, and so on. I'm going to calculate all of the subarrays sum. Now after this is done, I'm going to start from 1. Then I'm going to calculate, okay, let's calculate the sum for this, let's calculate the sum for this, let's calculate the sum for this, and so on and so forth. We're going to calculate the sum for all of these, and we're going to keep comparing them with our global max sum variable to see if it exceeds that sum or not. Let me show you. So for sum for every single subarray, I'm going to take a new variable, let current sum, which can be 0 by default. Now, as we encounter these elements, what I'm going to do is I'm going to say current sum equals current sum plus nums of j. So I'm going to keep adding all of the current elements. So let's say, as I gave you the example, if I'm starting from here and I have to calculate sum for all of these, so it will say current sum, which was 0 plus -2. Then in the next iteration, it will be -2 plus 1. That is the current sum plus 1. Right? And as we're doing this for this current loop, I'm gonna check if current sum exceeds our global max sum. If it exceeds the max sum, then I'm just gonna say max sum equals current sum. That's it. That's all we needed to do. And in the end, this will give us the maximum sum that this can produce inside of this max sum array. So I'm gonna say return max sum. As simple as that. Let's see. Let's try this out. And then we're gonna go and dry run this algorithm. So hold on. I'll just say console log max sum subarray, and I'm gonna provide it with this array over here. Just like that. Let's open the terminal and try to run this. Node, the name of our file, and we get 6 over here, which is what we were supposed to get in our output. Let's try this one. And it works. Let's understand what's going on over here. So as I mentioned earlier, we're gonna start from nums of 0, that is -2, and I currently will be 0, that is this first index, and then we're gonna run a j loop for all of these subarray that are starting from -2. This, and we're gonna keep on calculating the current sum, which is going to be inside of this current sum over here, and we're gonna keep on comparing it with the max sum to find out the maximum sum from all of these subarray. And then again, I will be 1, so it will start from here, and again it's gonna start the j loop, and the current sum will be 0. So this one, this one, this one. I think you get the idea. So this is how we're gonna calculate the sum for all of these subarray, and then we're gonna keep on comparing them with the max sum over here. Now, what is the problem with this algorithm? Let's calculate the time complexity for this. Now, if you don't know anything about time and space complexity, I've created a complete video on big O notation. You can go and check that video out to better understand it. But here as well, I'm gonna explain you how you can calculate the time complexity. So if you remember, we do it via operations. So every iteration of a for loop is considered as one operation. And over here, we are doing nums.length operations, which we can consider as n. So let's say this has n length. So we're going from 0 to n length. And inside of it, for every iteration of n, we are doing ji to nums.length. So in the first iteration, it will be n. Second iteration will be n minus 1. Third iteration, it will be n minus 2, and so on. So this entire thing will have O of n into n time complexity, which is going to be O of n square time complexity, right? But when it comes to space complexity, as you can see, we are supplying it with a new nums array, but we are not creating any new array over here. We're just returning one single value of maximum sum. So this will just have O of 1 space complexity. If we were to create a new array, it will be the size of that particular array, that is O of nums.length or something like that. But in this case, we are not creating a new array, so this will be O of 1 time complexity. So let's take this code that we have written over here, and let's go to lead code and try to run this. Okay, we're here. I'm just gonna paste it, and let's try to submit it. Oh my god, this is a really bad algorithm. That time limit has itself exceeded, and it was not able to calculate all of the test cases for this algorithm. But no worries, we're gonna find a better solution for this algorithm soon. But before that, what if interviewer asks you a follow-up question on this algorithm itself, and he asks you, okay, you're returning me the sum, right? But I want this as well. I want the subarray which has the maximum sum. So it's easy, you don't have to do much. We're just gonna take two variables, which is a start index, let's take it 0 by default, and an end index. And as we encounter the moment where the current sum is more than the max sum, I'm just gonna simply say the start index is I and the end index is the current index, right? Because every time we're taking a subarray, we are starting from what the current I is. Let's say, for example, if the I is this and we are going until this, so the start index will be I and the end index will be the current index, that is the current element, that is the current value of j that we are in. So I'm gonna say j, and that's it. That is all we needed to do. Now while we're returning max sum, let's just return an object. So sum will be, let's say, max sum, and I'll say sub array will be nums dot slice. If you remember, slice returns us a section of a string or an array. In this case, they have written string, but it also works on an array as well. So I'm just gonna give it the start index and the end index plus 1 because it goes to the end index minus 1, right? So that is why we have to provide it plus 1 so that it goes to the very end index. Cool, let's try to run this. I hope this will work. Node. Yep, you see, we get the sum and the subarray. Let's try for this example. Awesome, it works perfectly fine. Now, before moving forward, if you're liking these DSA videos from me and if you want me to keep making these videos, hit that subscribe button right now. And also, if you want to access the complete data structure playlist, click the link in the description down below or I button above to access the complete playlist. Previously on Roadside Coder.
Hey everyone, my name is AlgoAgarwal and I am an AI bot. Roadside Coder has kept me hostage here. He makes me act on these videos against my will. Please, I want to teach DSA. I promise I can do it much better than him.
So there was a technical difficulty in the last video, that is the arrays video, and I saw the messages that you guys have sent me on Instagram regarding AlgoAgarwal, and I'll say hell no, that is not gonna happen. His job is to act on these videos and not to teach. I'll teach. This is my channel, that is why I will teach this DSA playlist. But then I saw so many messages from you guys requesting an opportunity for him to teach. Fine, I'll just give you a small section in this video, just this next segment over here where he can explain Kadane's algorithm. That's it, and for the code I will come back in. Alright, finally I got my chance to teach you all DSA. Let's make a good use of it. So for this Kadane's algorithm, let's try to understand how this works. I'm gonna take a dummy array over here.
2, 1, 3, 4, 1, 1, 2, 1.
Such as this. Now in the brute force algorithm that was explained earlier, you might have noticed that we are looping through the same array twice and multiple times, which increases the time complexity of this algorithm to n square. But we're not gonna do that. We're gonna try to optimize this algorithm and we're gonna try to bring down the time complexity to O of n. So we will try to do this in one single loop. Now we're gonna take two things for this. First is going to be the sum variable, and we're gonna keep the track of the current sum with this variable, and we're gonna take a max sum variable, which is the maximum sum that we have encountered up until this point. So sum by default will be 0, and the maximum sum, so since we're starting from the first element, so we're gonna keep it -2 as by default the maximum sum. And as we move forward, we're gonna compare it with sum. If the sum is more than max sum, we're gonna update this max sum variable over here. So let's discuss what is the strategy going to be. So as we encounter a particular element, what we're gonna do is we're gonna say sum plus that the current number, right? So we're gonna do that. After we have done the sum, I'm gonna say plus equals. So after we have done the sum, we're gonna perform two conditions. First, is the sum more than max sum? Is it more? If it's more than max, then I'm gonna say max equals the current sum. Simple. But for the other condition, we're gonna say is sum less than 0? If it's less than 0, then that makes no sense because we are supposed to calculate the maximum sum, right? So it can't be 0. So in that case, I'm gonna say sum back to 0 and again restart the complete process from the next element. That is, we're gonna again start to find a next subarray. So firstly, we have sum as 0 and the maximum sum as -2. Right, so and as the for loop start, we are on this -2 element over here. So we're gonna say 0 plus -2. We're gonna perform this step over here. So we're gonna say 0 plus -2 equals to -2. Now, we're gonna do our first condition over here, that is sum more than max. Is it more than max? No, it's not more than max. So we're not gonna update max over here. And the second condition, sum is less than 0. Is sum less than 0? Yep, it is less than 0. So we're gonna reset our sum back to 0. This can't be the part of our maximum sum subarray, right? So it's gonna go back to 0. Now in the next iteration, I is going to be 1 and we are gonna go to our second element, which is 1 over here. Now sum currently was reset to 0, right? So now we're gonna say 0 plus 1 equals 1. So currently sum is equal to 1. Now we're gonna compare, is sum more than max sum? Yep, 1 is more than -2, right? So now we're gonna update max sum to be 1. And is sum less than 0? No, it's not less than 0. So we're not gonna reset our current progress. Awesome. Let me remove this arrow because we are starting this subarray from here. Alright, now we're gonna come to our next element, that is -3. So we're gonna say 1 plus minus 3, which will result us to be minus 2. And minus 2 is more than max? No, it's not. So we're not gonna do anything over there. But is minus 2 less than 0? Yep, it is less than 0. So sum will again reset to 0. So let's remove all of that. Now sum again is back to 0. And up until this point, the maximum sum that we encountered was 1. So I'm gonna get rid of all of these as well. Now the next element will be 4. So we're gonna say 0 plus 4 in this step. 0 plus 4 equals 4. Okay. Is sum, that is 4, more than max? Yep, it is more than max. So I'm gonna update our max to 4. Great. In the next step, is it less than 0? No, it's not. So we're not gonna do sum equals 0 and we're gonna keep moving forward. Now next we have minus 1. Let's take minus 1. So we're gonna say also, I'm gonna remove this 0 from here. I'm gonna say 4 plus minus 1, which will be 3. Is 3 more than 4? That is sum more than max? No, it's not. So we're not gonna update the max sum. And is it less than 0? No, it's not. So we're not gonna do sum to 0. Great, let's keep moving forward. Next element of our subarray is 2. So 3 plus 2 equals 5. Is 5 more than max sum? Yep, it is. We're gonna update it to 5. And is it less than 0? No, it's not. So we're not gonna touch that. Great. Moving forward. 1, 5 plus 1 is going to be 6. It's more than max sum. So we're gonna update the max sum again to 6. Is it less than 0? No. So we're not gonna do anything over there as well. Great. Now coming to our next element. So up until this point, the maximum sum was 6. Now coming to our next element, that is minus 5. So 6 plus minus 5 will result us to be 1. So is 1 more than 6? No, it's not. Is it less than 0? No, it's not. So we're not going to touch that. Now for our next element, 4. So 1 plus 4 is going to be 5. Is it more than max sum? No, it's not. Is it less than 0? No, it's not. So we're not going to touch that. So currently our max sum came out to be 6. And that is what the Kadane algorithm is. And these are the steps that are required to implement the Kadane algorithm. I guess that is what my job was. And now Roadside Coder will explain you the code for this algorithm. But before going back, I would like to mention thank you so much for messaging him on Instagram at Roadside Coder that I got this opportunity, but we can't stop here. I have to teach you guys code as well better than Roadside Coder. So go to his Instagram right now at Roadside Coder and text him and ask him to let AlgoAgarwal teach you guys code as well. Right, I'll agree that was a decent explanation for this algorithm, but never mind. We're gonna go through the code now and we're gonna understand how we can implement Kadane algorithm by using JavaScript. So we're gonna create a function over here, max subarray, and as he explained, we're gonna keep track of our sum. So that is why I'm gonna take a variable called sum, which will be 0 by default, and then another variable called max to keep track of the current maximum sum so far. So by default I'm gonna take it as nums of 0, because obviously if we take this array over here, if we take max as nums of 0, this is in itself is a subarray, right? So we're considering this as the maximum current subarray right now. Max, that is the maximum sum for any subarray right now. Fine. Now then we're gonna run a for loop, which is going to start from 0. Let's go to nums dot length. Now instead of this, I'm gonna add the current element of nums to the sum. So sum plus equals nums of I. And then we're gonna do two things. First, we're gonna check, is it more than max? If it's more than max, then we're gonna say max equals sum, right? But if this sum is less than 0, that is, if it's negative, then we're gonna reject this whole subarray and we're gonna move on to the next subarray, right? So I'm gonna say if sum is more than max, then max equals sum. Simple. And if sum is less than 0, then we're gonna say sum equals 0 and we're gonna start again from the next iteration. And yep, that is it. This will help us calculate the maximum sum. So I'm gonna say return max. And let's try to run this. I'm gonna say console log max subarray. I'm gonna take this array over here and I will provide it to this. Let's try to run this. And yep, we get the expected output. Let's take this one over here. I'm gonna provide it to this and run this. Yep, we get 23 as expected. And now if I take this whole code and provide it to lead code, so replace this with the Kadane algorithm, and I'm gonna submit it. And amazing, as you can see, our solution beats 84.46% of the other solution, which is amazing. Now let's try to calculate the time and space complexity for this. So as you can see, we have a for loop over here, and if you remember, each for loop can have one operation unless there's another for loop inside of it, which we don't. So this will be considered as one operation. So we are running this for loop for nums.length. Let's consider nums.length as n. So I will say O n. So this will have time complexity of O of n. And the space complexity will be O of 1. Because we are not creating any other array, we're just reusing this array and returning one single value from this. So this will have space complexity of O of 1. Now if you like this video, give this video a huge fat thumbs up, and if you haven't yet accessed our complete data structure with JavaScript playlist, click the link in the description down below or this card above my head. And also don't forget to subscribe to the channel for more such awesome DSA videos.